This is lesson 87 in Algebra 1, having to do with systems of equations and tests for functions. Alright, so what we're given in the very first example is, get a pen working, an R with a subscript E, T with a subscript E. Okay, let's make that look more like an R instead of a funny P. R. Okay, and that equals R, W, T, W. We also know that RE equals 200 and RW equals 250. Okay, so we know that they gave us that. They also told us that TE plus TW equals 9. They want us to find TE and TW. They want us to find out what numbers those represent. Alright, so remember when we've done these before, this is one variable. This is an explanation of what we're talking about. So if we're talking about how many raisins Edward ate, this would be raisins Edward ate. If this is how many tacos Edward ate, it would be tacos Edward ate. So the E would represent specifically who ate the raisins and who ate the tacos. Okay? So that's all that is. It's just a further explanation of what this is. So this is one variable, this is another. So we have 1, 2, 3, 4 variables. So let's plug in the information that we've got and see if we can solve this thing. Okay, we know that if we replace RE with 200 over here and RW with 250 over here, we get an equation that looks like this. We'll do it in red. 200 for RE times TE equals, from right there, RW, which is 250 TW. Okay, that makes life a little bit easier. Alright, we also know that TE plus TW equals 9. Well, if we took this and switched it around, and instead of made it TE plus TW is 9, let's say we subtracted TW from both sides itself, and we get 9 minus TW. Alright, so by doing that, by taking and changing it around like that, I can say that anytime I see a TE, I can put a TW in its place. Alright, and I'll show you why I'm doing that in just a minute. Don't forget to put those in parentheses. Alright, now, look at this in blue. How many variables do I have? I have one, a TW here and a TW there. They're both the same variable. One equation, one variable. I can solve this now. So this is going to be 9 times 200 is 1800 minus 200 TW. Okay, I distributed the 200. Alright, now I'm going to add 200 TWs to both sides to get the TWs all together. Those go away. And I end up with 1800 equals 450 TWs. And if I divide both sides by 450, 1800 divided by 450, my TW is going to be equal to, because those will cancel, is going to be equal to 4. Nice, because now I can take that and plug it in here and find TE to be 5. 5 plus 4 is 9. And I'm done. Alright, let's look at example 87.2. Okay, here's the example. RT plus this is 360. They give us an R1 and an R2. They tell us if we add the two T's together we get 10, and we're looking for T1 and T2. Alright, so let's take the long one and we'll plug in what we know. So whenever we see an R1, we're going to put a 30. And when we see an R2, we'll put a 40. Okay. Now we're going to take this and write it. You can either make it equal to t2 or t1. Let's make it equal to t1. We're going to subtract t2 from both sides so that we have t equals 10 minus t2. So now whenever we see a t1, we're going to put 10 minus t2 in its place. So we'll do that in blue. Don't forget to group. You've got to group these, because t1 equals 10 minus t2, not just one or the other. Alright, so same thing happened. We have a t2 and a t2. We have one variable. So we have 300 minus 300 t2, because we distributed, plus 40 t2 equals 360. Okay, so let's add these two here. 300 oh, there shouldn't be a 0. Sorry about that. 30 times t2, that should just be a 30. Probably got you like, oh, will you change that? You made a mistake. Alright, then we subtract 300 and subtract 300. Sheesh, I don't know if you can hear my neighbors or not, but they're so loud. 4 old people over there just laughing. Okay, this is going to give me 60. Divide by 10. Divide by 10. My t2 then is going to be 6. Now I'm going to take my t2 is 6 and put it in here and find out what I add to 6 to get 10. And that t1 then is going to be 4. And that's what I'm looking for. Alright, test for functions. Now we've talked about functions and what those are back in lesson, gosh, I think it was 84. And now we're going to look at being able to tell if a graph is actually a function. Okay, it's a pretty easy way to do it. It's kind of cool. Alright, so we're going to just put a graph on here. Let's just do this graph right there. Alright, so the way this works is if you can draw a straight line down anywhere on this graph and have it go through the graph at more than one point, it is not a function. Now if you look at each one of these red lines, they only go through this graph here at one place. So it is a function. But if, let's say I've got a graph here, and let's say my graph is a circle, and I draw a straight line down, I crossed here and I crossed here. So a circle is not a function. It also works if I have a graph, and it's not necessarily a circle, but let's say that I've got my graph here, and I go like that. Now if I draw a line down here, it goes through one place. But if I draw a line down here, it goes through 3. So if there's any time where you can draw a line through the graph, doesn't matter if all the other ones only cross at one point. If you can find a line that crosses at more than one point, like we did here, not a function. Alright, so let's see, a couple more not a functions here. If we have something like this, and we have a graph that looks like that, which we will, you cross here, crossed 2 places, not a function. But if we have a graph like this, and it does this, then we have a function because it only crosses at one point every time we draw a line. Okay? So that determines whether or not it's a function, and it's called the vertical line test. And that's it for lesson 87.